Okay, this question starts easy but has a tricky bit at the end, but there's a procedure for that you just need to learn, really. So it shouldn't be that difficult if you know the procedure. So part A, we just need to do some substitutions. We substitute 1 into this expression and we get 2, and we substitute 5 in and we get 6. And it's just some free marks, really, for those simple substitutions. Okay, but then we need to plot those points. So on the grid, draw the graph. Okay, so we use those values from that table and we plot the points. There we have it, and then just say to draw the graph, not just plot the points, so we need to draw a smooth curve. Now, with cumulative frequency, you can get away with connecting the dots with straight lines using a ruler. You can't do that, and you shouldn't do that. It doesn't actually make sense to do that with a graph, a quadratic graph. Quadratic graphs are curves, U-shaped curves, so we need to draw a curve. So you need to take your time over it, use a pencil, try not to do a furry line. You want to end up with something that looks roughly like that. We know what quadratics look like, so we sort of know what to expect. I've seen some candidates drawing a straight line across here. For some reason they don't feel like the graph is somehow not allowed to dip below. It has to dip below. If it's passing through here and it's a smooth curve, it must go underneath. So you do need to draw it going underneath. Okay, part C. By drawing a suitable straight line on the grid, I have to estimate the solutions of that equation. Now, because it specifies a way to solve the equation, you are not allowed to just rearrange it and use quadratic formula or something like that. You get no marks for that because it tells you it wants you to do it in a particular way. And this is how to do it. You first need to compare the left-hand side of the equation. Sometimes it's the right, but in this case it's the left. Compare in this case, the quadratic side of the equation with the curve equation, or the expression. Well, it's very similar, isn't it? We've got the x squared, we've got the minus 5x, we just don't have the plus 6. But we need, if we're to use this graph to solve this equation, we need this to look the same as the original curve expression. So what do we need to do to both sides of the equation? Should be obvious, add 6. So I'm just going to rewrite it, but with a plus 6 on both sides. So just to recap that, because I think it's a really important point, the bit that's unhighlighted here is exactly the same as the original equation, but I've got a plus 6 on both sides, and the reason I've got a plus 6 is because that's what we need to make one of the sides of the equation look like the curve. Okay, so this is like solving simultaneous equations now. Imagine that you had y equals x squared minus 5x plus 6, and separately y equals x minus 7 plus 6. Well, the first thing you would do would be to set the two x expressions equal to each other, i.e. arrive at this. So you have here the equivalent of finding the intersection of a curve, this curve, with this straight line. So we need to plot this as a straight line. And the line to plot is x minus 7 plus 6, but obviously that simplifies to y equals x minus 1. So plot the line carefully, making sure that you acknowledge that you've got two different scales on the axes here. It's gradient 1, so it must go along 1 and up 1 to get back to the line, and its y-intercept is minus 1. And we're interested in what the x values of the intersections. Remember, the equation we're solving has only got x's in, so we don't care about the y values. So whilst the intersections are here and here, we only care about these x values here. And that's it, we just need to write down those values. And I think they're only estimates because this is a hand-drawn graph, so we're not going to get the exact values, and therefore it doesn't make sense to round to too high an accuracy, because we just can't be that precise. So I'm just going to round to the nearest 0.1, so I'm going to go with 1.6 and 4.5.